My name is Ian Fryer. I'm the Engineering Director for RMD Kwikform. Today we're in London at King's Cross, where I'd like to take you and show you some of the details of RMD Kwikform's new Ascent Screen system. On this project, we're using it to help build a 27-storey student accommodation block. Come with me now and we'll go and see some of the details up inside this building. Before we go up to the top of the building, I thought I'd show you how the Ascent screens are delivered to site. This set of 3 screens has been delivered to site as a stack. You can see they nest efficiently, which means that 3 screens can be put onto one lorry at one time. Let's go and see the screens in action. Here we are up inside the top of the building. This slab is waiting to be concreted, but we're standing within the 4-metre high protection that's afforded by the top level of the Ascent screen. This is not the top of the Ascent screen. Each screen module is 12 metres high, and the cantilever between the top of the screen and the first set of slab brackets down below is 6.5 metres. The guys working at this level don't really know that they're working up at a high level because there are no gaps in the screen. This reduces operative vertigo and increases production on site. Also, the seals between the screens and between the screens and the building make sure that no debris can leave the construction face and fall down onto the city streets below. Extremely important into a city centre environment. Here we are at the corner of the building. In this location, you can see how the telescopic Ascent cladding beams enable the equipment to be extended in order to make a system seal at the corner. There's a mitered joint between the 2 screens, which results in the entire corner being made using system equipment. At the corners, you have this compressible seal, which we saw during the manufacturing phase, and it's that gives the no gaps finish between the Ascent screens and again prevents debris from exiting the building. I'm standing now on the 1.2 metre wide platform that's mounted on the Ascent screen. This platform is at the same level as the surface of the forcework which is used to form the soffit. The advantage in that is that 2 can be easily sealed together by this plywood, leaving a small gap so the screen can be lifted later. Also, operatives can move freely between the 2 when they're fixing reinforcement, and also this platform can be used to store up to a tonne of materials per Ascent screen. Really useful in the confines of a high-rise construction. In terms of sealing against debris, as well as the plywood seal that you have between the soffit and this platform, you have a PVC seal between the PVC sheet and the plywood. On the back of the PVC sheet is welded a flap which comes down and is then nailed using a batten onto the surface of the plywood. That gives a continuous seal between the PVC and the plywood and makes sure that no debris can escape downwards through the system. Really important.
Dan Linehan, the site manager here for Atlantic. We're here in King's Cross. We're doing the T6 project, which is a student accommodation. We're on York Way. We're right next to the Eurostar rail link going into King's Cross from Europe. Atlantic are the first company to do the Ascent system from RMD Kwikform. Reason being, it's very, very easy to put up. Safety is a major issue on any job. The RMD Kwikform we have here is very good, keeps everything contained. There's no chance of any debris from falling down into the floors below. It's a high-rise apartment block we're building. It's 27 floors. So anything falling down would be a big deal. So this system we use is very attractive. It's very good.
Here we are underneath the forcework deck. Up above me, you can see the platform that's mounted on the Ascent screen. And here, the formwork that sits on top of the forcework. The gap between the 2, and the 2 existing at the same level, and the seal that's afforded by the plywood strip that we saw from above. Coming down to the next level, you can see the seal between the next slab down and the Ascent screen, afforded initially by this plywood, but in the secondary fashion by another plastic flap that is secured and welded to the back of the PVC, that is brought out and then fixed using a batten onto this plywood. Finally, in this location between the screens, you have a Velcro flap which is used to seal up the joints between the horizontal sections of the screen section. All of these seals are intended to be very quickly removed so that the screen can be lifted, and then once lifted they can be replaced to effect a safe, secure seal against debris egress.
when we go to do the decking, the screen has got an inbuilt platform on the inside, which acts like a handrail system. The turnaround we're doing up there at the moment, we're doing it in 6 days. There's no need for temporary handrail systems. The handrail's already there. The cycles are turning around very quickly.
Here we are now down at the back propping level, one level below the false work. You can see behind me a third line of defence against debris leaving the building. Another complete debris skirt running around the perimeter of the building, sealing between the concrete face and the face of the PVC cladding. So that's 3 levels of debris protection. One at the back propping level, one at the false work level, and one at the deck level, making it very difficult for any debris to escape the building. Another thing worth noting about the Ascent Screen is that the PVC sheeting is translucent. A certain amount of light can pass through the sheeting at this level, meaning that lighting is not necessary for the site. In this area too, you can see the debris seal between the 2 buildings, this soft PVC seal that provides you with no gaps and gives you the ability to take up any tolerance between the various screen modules.
When they're up in place, it just takes 2 or 3 minutes to lift them up by crane, take off the chains, move them onto the next screen and keep going until they're all complete.
Now the screen has been successfully lifted, you can see behind me the reason why the screen is so important on this job. The railway line in the background is High Speed 1, the main railway link between London and Paris. The consequences of any debris leaving this building and falling down onto that railway line do not bear thinking about. Once the screens have been lifted, you end up with a barrier around the perimeter of the building over 6 metres tall. And it's against this barrier that the false work can then be erected, ready to form the next lift.
The benefits are all the work is done in the factory before it comes on the site. The screen's already made up, it's good, I'm happy with it, and I definitely recommend it. It's one of the better ones that I've used other ones, and this would be right up there.
Now I'm standing on the Ascent Screen loading platform, a platform that projects at the level below the anchorage to enable formwork materials to be cycled from below, moved out onto the platform and quickly craned up for reuse up on the working front. The capacity of this platform is 2 tonnes, and at the moment you can see they've got a rollover skip here where they're clearing out the debris from the level below so that it can be craned away. It's really useful to have the ability to move materials out from below and crane them quickly up for reuse.